Okay. This is the Teamful group. We have about like 20, more than 20 members. Okay, if you are interested, you can visit the group web. Okay, so this is the outline on my today's talk. I will have a brief mention of automated organ design, then introduce our work named EOH and the LLM4AD platform, which is an open source platform for based on the organ design, and mention some applications. Okay. Um, so basically we serve as I think all of you are doing some agentic system based for decision making, right? So basically we serve automated algorithm design as an optimization problem in algorithm space. Okay, so we have problem space, we have algorithm space, we have performance measure, then we can search in the algorithm space, and now we have a large language model, so we can directly generate algorithms and code. That's clear, right? So, but actually, automatic algorithm design has been studied for at least decades. We have selection, automate like genetic programming. We have automatic algorithm convolution. We have AutoML, learn to optimize. We have all these different approaches, and now we have AI-based, AI-driven automatic algorithm design. So I think that like with AMs, we are opening new possibilities, but we also inheriting the decades of lessons from EC, both evolution computation and the optimization. Okay, so these are some I think these are incomplete list. If okay, and so when we listed them different approach together, we look better into history. So that's there are two aspects. One is where the algorithm space, and how to find the optimized algorithms. So basically, we have some approach search on the continuous space, like parameters. We have some approach like just to directly generate algorithms code. Okay, so when we look back, what has changed? There's a few things has changed. Like the algorithm space has changed, the representation has changed. We have priors, right? So like with AMs, we can directly generate the code and the algorithm concepts, but more things not changed. For example, we still need an iterative search pipeline to make it effective. And we have exploration and exploitation trade-off. We have diversity consideration. And we also have like a generalization issues. We cannot outcross distribution generalization is hard. Okay, so I want to say that we are still facing these long-standing points, which we can learn, which is also is challenging, but it's also opportunities for innovation because we have many we can learn from these decades of research field. Okay, so I will mention UH evolution of heuristics. I think all of you are using some similar pipelines, right? So we proposed in 2023. Um, I will not go to details because all of you know like the basic pipelines. We iteratively generate algorithms with evaluation, and we evolve to a better algorithms. Okay. Um, Here are the timelines. I like we didn't list all. We just have a brief comparison with Google. So we propose it. So our first so we start in 2023, and we publish our first work earlier than from search, and then we got some other progresses and publications, and like we in 2024 we have LLM4AD platform, which is open source. Um, and after that, we have some extensions, like we have multimodal AMs extension, and we have some application studies, and we have some agentic uh, applications. Because of time limit, I will not go to every works. Okay, so this is our platform. It is Like we have, I think we have more than 10 methods, search method. We have more than 100 optimization tasks across different fields, occupation, machine learning, science discovery. Okay, we unified, modularized each part, and we have some many supports for your usage. You're interested, you can scan and for like in I think in 1 week or in 2 weeks we will release the version 2, which is cooperated with Huawei, um, where we have more automations. We integrated the agentic pipeline so that we can directly input language and then it will design algorithm, which is very convenient. Okay. So for the application, I will only, as I mentioned, there are more than 100 applications. I will only mention some of them. First one is a cycle packing problem, which is like we have a cycle, we need to pack we have a pack cycle into boxes and to maximize ratios. Okay, and actually AlphaFold also tested this problem. They got a new record better than human design, and we tested. We got a better one than AlphaFold and also Express. Okay, and we are open source. We are like here's a competition on AM based for black box optimization. We use UH and LLM4AD to design the meta heuristics, and we got the champ. We win. We are the winner. Fortunately, and this is the CVIP Lib. That's a known solution competition, which is you know vehicle routing problem, large scale vehicle routing problems, and we also win the champion, and we generate 51 best new best known solutions with the automated designed algorithms. Okay, and we also applied on other applications like CUDA kernel design. Uh, so like I think all of you know what is kernel, right? So these are the results. We have a maximum speed up of 36%. I mean, it's not the average speed up, but on some kernels, right? But in average, it can have some improvements. And also science discovery. We have used it to discover the function in computational fluid dynamics. And you can see here, like this is the human designed simulation function, and this is the automated design one. Yeah, it looks better. And also automatic research, automated paper generation. If we have UH, then we can like let it to discover new algorithms, and it can automatically generate a paper. It's like the paper generation is like some engineering, like okay, it's the paper automatically generated without any human like revision. Okay, so because of the time limit, so this again the platform you can scan if you're interested, and I yeah, so in the end there are some thoughts. I think like there are two main components in this pipeline, in this approach, right? The one is AM, the other is the iterative search, sometimes usually evolutionary search, but not always. So in this pipeline, in this paradigm, AMs are like mimic human experts with some domain knowledges and for code and language generation, and the iterative search process is make the try and error of human experts. Okay, so despite the advance of AMs, I think the iterative say or evolution search will still remain essential, at least in the near future. And I think researchers should focus on understand how and why certain search and iterations work or not. And we also need to know what to automate and where's human, right? Now we have more automations, so where should researchers, human experts, in this algorithm design framework pipeline? And we can focus on some killing real world applications to make a real impact. not only testing some benchmark instances. Okay, okay. I hope that we can moving from excitement to deeper understandings and collaborations in this event, because we are all working on related, very close areas. And I think it is very promising approach for algorithm discovery. Okay, if you're interested, you can visit the website or you can contact me. This is my email. Okay, thank you.
All right, thank you so much, Fei Liu, for the insightful talk. So if the audience have any questions for Fei Liu, feel free to type them in the chat. For now, for the time's sake, perhaps we could move to the next speaker. Oh,
Let
sorry.
us
Maybe
stop
then
sharing.
do you want to ask some quick question here? How much experience do you have with these frameworks combined with expert domain knowledge?
Yeah. I stopped sharing, but I can just brief report you mentioned. It depends on your tasks, right? For some benchmark tasks or commonly studied tasks, for example, the black box optimization and the combinatorial optimization, because I think they have AMs already got much knowledge on it. So we basically only provide the algorithm template, like what we want algorithm to design, the input, the output, and the evaluation feedback. Then it will do everything else. Yeah, but for some apart tasks, for example, the kernel design, there are not much domain knowledge. I would say you need to in order to make sure the effectiveness and efficiency, you need to provide some additional component, for example, to fix and to evaluate and check. Then, but still, like it can be effective. It can like to replace the most time-consuming and the tedious part components. Yeah, it depends on your tasks, I would say.
I see. Thanks for the answer. And maybe we have time for one quick question here. So you mentioned that LLM4AD won the CVPR Leap Challenge, right, for finding the
Yeah,
new best known solutions. We
yeah.
know that these systems are usually effective in improving benchmark that they've been exposed to. But how do you think they are capable of creating new general purpose algorithms that transfer to unseen problem classes just on the benchmark that they're trained on? What are your thoughts on this?
Hmm. I think the questions are about benchmark and the real world application. Is
Yeah,
that
like generalization to like new unseen tasks, not just on the benchmark instance.
generation. Yeah. That's a really important question and still challenging for this field. Yeah, and I don't know if I can sh still share the screen or that's no time. Okay, I can still. I just mentioned maybe. Okay. I think it is an issue in. I mean, not only AM based algorithm design, but also automated design itself. Maybe you use other methods, use a deep learning based approach, neural software. You still need to face a generalization issue. But I think that we can have many different approaches to solve it. Actually, in this year and last
Mm.
year's Europe and SML, we already have some new revisions of UH approach to solve like cross distribution generalization. For example, we can design some complementary heuristics, which some are good. For example, in a very simple setting, some are good at small scale instances, some are good at big, large scale instances. Yeah, that's one case.
Mm.
And also, I think in last year's AR, there are paper on meta optimization. Like you can learn some principle, high level algorithm, meta heuristics. Then you can do some adjustment to different
Mm.
distributions. Yeah. Yeah, I think you can have different approach to enhance the generalization, but it is an issue, like challenging. Yeah.
Right, right. I agree. I think generalization is like one current big open question for this field. And also stay tuned for our panel session later because like we also mentioned this in our panel session. But for now, thank you again, Fei Liu, and maybe we'll move on to the next speaker.